Hello and welcome. Have you ever wondered how a store figures out the price of your groceries? Or how your GPS estimates your arrival time? Well, the answer is all about a core math concept: proportionality. It's kind of like the hidden logic that connects different things all around us. And today, we're going to break it all down step by step. Now, before we get into the theory, let's start with a real-world puzzle. We've got sheep, we've got fodder, and we've got time. And all of these numbers are changing. It looks pretty complicated, right? But don't you worry, we're going to build a logical framework together that will make solving problems just like this one feel totally straightforward. So here's our game plan for today. We'll kick things off with the basics of direct proportion and see what that actually looks like on a graph. Then we'll flip that idea on its head and explore its opposite, inverse proportion. Once we've got those tools in our back pocket, we'll put them to the test by solving some problems. And finally, we'll wrap it all up with a quick summary. Sound good? Let's get started. Okay, let's dive right into our first section, direct proportion. You know, the core idea here is actually really simple. It's just about two things moving in sync. If one of them goes up, the other one goes up. If one goes down, the other goes down with it. Simple as that. Now, in mathematical terms, we say that y and x are directly proportional if their ratio, that's y divided by x, is always a constant value. A great way to think about this is like the price per item at a store. Whether you buy 1 apple or 10 apples, the price per apple stays exactly the same. And that constant ratio, that is the absolute key. This example with library fines makes the idea crystal clear. Look at this. 1 day overdue, you owe 15 cents. 2 days, it's 30 cents. 10 days, it's 150 cents. See the pattern? As the number of days goes up, the fine goes up right alongside it. And that constant ratio we just talked about, it's always 15. The fine divided by the number of days, always 15. We can capture this whole relationship in one simple little equation. Y equals kx. That letter k is our superstar here. It's the constant of proportionality. In our library example, k was 15, right? The price per day. Finding this constant is pretty much always the first step to solving any direct proportion problem. It's the key that defines the entire relationship. Okay, so we've got the formula down, but let's see what this relationship looks like visually. An equation is one thing, but a graph can tell the whole story in just a single glance. So what does a direct proportion look like when we plot it out on a chart? Let's stick with our trusty library fine data. So on the horizontal axis at the bottom, we'll plot the number of days a book is overdue, and on the vertical axis, we'll put the fine in cents. This gives us a really clear set of points to put on the graph: 1, 15, 2, 30, 3, 45, and you get the idea. And when we actually plot those points, there it is. This is the visual signature of a direct proportion. Two things should jump out at you right away. First, the points form a perfectly straight line. And second, that line passes directly through the origin, the point 0, 0. And that makes perfect sense, right? 0 days overdue means a 0-cent fine. Excellent. Now that we've totally mastered direct proportion, let's explore its opposite, inverse proportion. And just like the name suggests, this describes a relationship where two things move in opposite directions. As one value goes up, the other one goes down. A perfect real-world example of this is the relationship between your speed and your travel time. I mean, think about it. If you're on a 120-kilometer trip and you travel slowly at 10 kilometers per hour, it's going to take you 12 hours. But what if you double your speed to 20? You cut your time in half, down to 6 hours. Crank it up to 60, and your travel time drops to just 2 hours. More speed means less time. Now, here's the key difference. With inverse proportion, it's not the ratio, but the product of the two variables that stays constant. The formula is x multiplied by y equals k. In our travel example, speed times time always equals 120, the total distance. 10 times 12 is 120. 60 times 2 is also 120. See, the product never changes. So it probably won't surprise you that the graph for an inverse proportion looks completely different. It's not a straight line at all. It's a specific kind of curve called a hyperbola. See how it swoops downwards as you move to the right? It also never actually touches either axes, which makes sense. You can't complete a journey in 0 time, and you can't travel anywhere if your speed is 0. All right, now for the really practical part. We have the theory for both types of proportion down. Let's move on and use this knowledge to solve a classic word problem. This is where the rubber meets the road. Okay, here's our problem. 8 men can build a bridge in 12 days. The question is, how long will it take 6 men?
Now, the very first step, before you do any math at all, is to just think about it and identify the type of relationship we're dealing with.
Let's walk through this together, step by step. Step 1. Identify the relationship. If you have fewer men working, the job should take more time, right? One quantity goes down, the other goes up. Ding, 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 that's an inverse proportion. Step 2. Write down the correct formula, which is men multiplied by days equals our constant K. Step 3. Find that constant K using the info we have. 8 men times 12 days gives us a constant of 96. And finally, step 4, use that constant to solve for our unknown. 6 men times our unknown number of days must also equal 96. A quick division, 96 divided by 6, gives us our answer, 16 days.
Wow, we've covered a lot of ground today, so let's bring it all together in our final section with a really clear summary of the key differences you need to remember.
Okay, this right here is the core takeaway. For direct proportion, think y equals kx. That gives you a straight line through the origin. For inverse proportion, think xy equals k, and that gives you that cool, swooping curve. The formula and the shape of the graph, those are the two essential things to remember. If you can remember these two patterns, you'll be able to identify and solve pretty much any proportion problem that comes your way.
So as you go about your day, I've got a little challenge for you. Start looking for these relationships. Think about the number of hours you work and the money you earn. Or maybe the number of people sharing a pizza and the size of your slice. Which one is direct and which one is inverse? Once you start looking for these mathematical patterns, I promise you'll see they are truly everywhere. Thanks for joining me.